The need for energy, especially fuel, will continue to increase in line with population growth and technological advance. The increasing need for energy has led to higher exploitation and consumption of energy from petroleum.
Assalamualaikum warahmatullahi wabarakatuh.
Hello, let us introduce ourselves to you. My name is Ayunda Puspa Fathma Azzahra and
I'm Halimatul Aniyah. We are from Manila, Madrasah Aliyah Negeri 1 Lamongan.
Here we would like to present our innovation with the title
ENFISEL, Environmentally Friendly Biodiesel Transesterification of Used Cooking Oil into Biodiesel with Activated Charcoal Catalyst from avocado peel and moringa seed.
Scarcity of energy source is a serious problem. In 2019, oil production was about 21 million barrels. In 2020, it was about 19 million barrels, and in 2021, it was about 17 million barrels. From this data, it can be seen that oil production will continue to decline every year, and this indicates that energy reserve will continue to run low or even run out, especially non-renewable energy.
The potential for used cooking oil is very large, namely around 1.2 million kiloliters per year. Traction Energy Asia research result also found that 1 liter of cooking oil used by a household produced 0.4 liters of used cooking oil, and 1 liter of cooking oil used by SMEs produced 0.32 liters of used cooking oil and has not been utilized optimally. BPS records the avocado production in Indonesia in 2021 will reach 669 tons. This number increased by 9.89% compared to the previous year. With a very large production, of course, a lot of avocado peel waste is also produced. Likewise, with moringa, which can grow in very dry and extreme areas. Each moringa tree can produce between 15,000 and 25,000 seeds per year.
The goals of our research are, first, to find out the process of making biodiesel made from used cooking oil using avocado peel charcoal and moringa seed charcoal as catalyst. Second, to explain the effectiveness of biodiesel made from used cooking oil using avocado peel charcoal and moringa seed charcoal as catalyst. Third, to describe the results of tests on the physicochemical properties of biodiesel.
The tools used in our research are beaker, filter, filter coat, funnel, scales, cans, pH paper, bottle, tricks, thermometer, oven, baking sheet, spatula, pan, electric stove, and scissors. Meanwhile, the material used in our research were used cooking oil, avocado peels, moringa seeds, methanol, sodium hydroxide, distilled water, spiritus, meats, gasoline, and activated charcoal.
There are 5 stages in making ENFISEL. First, collection of tools and material. After that, used cooking oil that has been obtained is filtered and left to stand for 12 hours, then heated for 30 minutes. Second, making activated charcoal. Avocado peel that has been cleaned is baked in the oven for 45 minutes at a temperature of 100 degrees Celsius. Then the avocado peel and moringa seed are burned to become charcoal. After that, both of them were activated using sodium hydroxide for 18 hours, then washed using distilled water until the pH is neutral and put back in the oven to dry. Third, the transesterification process. In this process involves used cooking oil, methanol, and catalyst, which are then mixed with a sample, stirred in beaker glass, and heated on a tripod for 180 minutes at a temperature of 65 degrees until 70 degrees Celsius, which is controlled by a thermometer. Fourth, biodiesel testing. After the transesterification process, the mixture of used cooking oil, methanol, and catalyst is filtered through filter paper for 72 hours. The biodiesel yield obtained was then tested for its physicochemical properties. And the last, ENFISEL packaging.
In our research, there were 6 samples as in the table. The used cooking oil was 134 grams and 11 grams of methanol. Comparison of activated charcoal from avocado peels and activated charcoal from moringa seeds, namely 820, 622, 424, 226, 028, and sample 6 as a control using ordinary charcoal as much as 8 grams. From the table, it was found that the highest biodiesel yield was found in sample 3 of 73%, then sample 4 of 63%, and the lowest biodiesel yield was found in sample 5 of 41%.
On the density test, it was found that sample 1, 2, 4, and 5 meet the biodiesel density standard, namely 0.85 until 0.89 grams per milli. Whereas in sample 3 and sample 6, namely ordinary charcoal as a control, it does not meet the biodiesel density standard. From the table, it is known that the pH of biodiesel that meets the requirement is 1 in sample 2, 3, 4, and 6 with a pH between 6 until 7. In sample 1, it has a pH of 4 where the conditions are acidic, as well as sample 5 which has a pH of 5. The acid number test was carried out using a phenolphthalein indicator and titrated. It is known that all samples meet the biodiesel acid number standard, namely maximal 0.8 mg kalium hydroxide per gram. Sample 1 is 0.2, sample 2 is 0.5, sample 3 is 0.8, sample 4 is 0.5, sample 5 is 0.2, and sample 6 is 0.5.
Organoleptic testing was carried out with 3 indicators, namely color, aroma, and texture. The best sample was obtained by sample 6 with a yellow indicator, pungent aroma, and slightly thick texture. From this research, we can conclude that from the 5 tests, it was found that sample 4 with activated charcoal from 2 grams of avocado peel and 6 grams of moric acid was the best sample and most will violate the biodiesel standard with a yield of 60%, density of 0.89 gram per milli, pH 6, acid number 0.5 mg kalium hydroxide per gram, and organoleptic test result. So sample 4 was brown in color with a medium thin and slightly thick texture. ENFISEL, renewable energy for better future. That's all for our team presentation. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.